Yeah, so we are good to go. So, good morning once again to everyone. My name is Saurabh, and today we will go through the webinar on PLC, circuit design using PLC. Okay, so this is the agenda of today's PLC, today's webinar. Okay, so we are going to see the circuit design using the Siemens PLC, then the flexible wiring. Then we will see the illustrated library, illustrated PLC, maybe using the virtual trainer kit. Okay, and then we are going to see one example of virtual system. Okay, and the industrial examples. Okay, I hope I am audible to all. If anybody has any question, please type the question in the question pane. Right. So talking about our company, we have a team of 150 engineers and software specialists. We are ISO certified company and we were founded in 1986. We are leading the industry by designing world-class trade-oriented tools in the fields of fluid power, electrical engineering, industrial automation, and custom software development. We have three offices. Our headquarters is at Montreal, Canada. Two branches, one is in Mannheim, Germany, other is in Pune, India. So we have expertise for software, okay, then engineering and industrial automation. So we have a software specialist for software engineering, database design and support, network support, multimedia applications. Then we provide engineering support. We work on pneumatics, hydraulics, mathematical modeling, electrical systems, automation, then robotic systems. We also work on PLC programming, SCADA systems, HMI, electrical controls, okay, then system maintenance. So these are our products. We have Automation Studio Professional Edition to create, analyze, troubleshoot, and validate multi-technology circuits. Then we have Educational Edition to train future technicians and engineers on hydraulic, pneumatic, electrical, robotics, process control, and PLC systems to simulation. Then we have Live Manifold, which is a complete hydraulic manifold software solution for design, coding, and prototyping. And then we have Anden Studio to it is a complete solution to optimize your production, or you can say more related to Industry 4.0. Okay, so these are our objectives. We believe in long-term relationship. We will have a effective support by phone, email, or online. We provide a dedicated representative for each account, and we also provide support material like training videos, demonstration files, quick start guides, etc. So these are some of our milestones. As we started in 1986, we were then known as Hydrosim and Neosim. In 1996, we started with Windows-based version that was Automation Studio 1.0. From then till now, as per the customer's requirement and their feedback, we are progressing. And currently, we are working on Automation Studio 9.0 and the third version of Anden Studio. Yeah. So what is exactly Automation Studio software? So Automation Studio is a multi-user collaboration sharing software which deals in various fields like simulation animation, trade-oriented system design, and machine documentation. You can draw your circuits on hydraulic, pneumatic, manifold blocks, some part of mechanical, electrical systems like electrical control, electrotechnical one line. We have a separate library for digital electronics, instrumentation and process control, robotics. Then you can draw the circuit on PLC ladder logic, which we are going to see today. Then block diagram. You can also link your circuit with the hardware kit or the trainer kit using CAN bus, OPC client. Then SFC. We have some extraordinary features like workflow manager, FMEA, teachware, manufacturer's catalog, bill of material and reports. Okay. And it fits for multiple programs as you can see here. What are the key benefits of um, Automation Studio with respect to students, teacher, and school? For student, it validates theory studied in class. So whatever a student is studying in his or her textbook, so they can validate that theoretical part in Automation Studio. So they can draw the circuits. Okay, they can simulate them. Okay, you can like they can be able to get the illustrate systems behavior dynamically in full color. And for teachers, it facilitates demonstration of system interaction. It enhances teaching and learning by working on virtual system. No need to purchase a single technology software as it is a multi-technology software. You can use more than one technology in conjunction with other departments. Okay. You can also provide e-learning or remote access to students. Okay, and students can use it at home. They can do project works and like homeworks at home. We have an international presence. We are available in 13 languages and we have sold our software in 150 countries. So our software is used by high school, career centers, colleges, universities, workforce development. We also provide technical publications in Automation Studio. For example, you can see this circuit. This circuit is from this technical publication, that is Fluid Power with Application by Anthony Esposito. Similarly, there are many other circuits available in Automation Studio from different publications. Okay, so student can just go to technical training material tab and click on the exercise which they want to work. You can also create some interactive exercises in this way. Again, there are some built-in interactive exercises available in Automation Studio, which are easily customizable and you can create your own exercise. You can create digital twin of your own equipment if you are using any such kind of trainer kit. Okay, so you can see this circuit here on the trainer kit. The same circuit we have drawn in Automation Studio and we have linked with the trainer kit. So in this way, like you can create the digital twin of your own equipment. We also provide illustrated libraries in Automation Studio. So we have libraries for PLCs, hydraulics, AC/DC motor control, pneumatics, then aeronautics, sectional components. Okay, so this is like three ways to create, simulate, and troubleshoot in Automation Studio. So you can use the circuit using create the circuit using ISO symbols, then illustrate components, and you can use virtual trainer kits also. Okay, so this is this like you can see the actual trainer kit, pneumatic trainer kit, and the virtual trainer kit also here. You can see. So this components which you are seeing on the left hand side, the same components we have created, okay, designed in Automation Studio. Right. Yeah. So also you can also like create the circuit in Automation Studio using the illustrated components and then the flexible wire pipes you can see. Yeah. So what are the benefits of virtual plus hands-on experience? Um, so if you are using a hardware kit, only hardware kit, so only two students per unit can work on that hardware kit and it will be an expensive option. But if you are using hardware kit with Automation Studio licenses, there are multiple benefits as you can see here, and it will be really an like affordable option. So one of the most important feature of Automation Studio is the manufacturer's catalog. So we have pre-configured ready to simulate manufacturer specific products available in Automation Studio, okay, which each and every student can use it. So they will be able to learn the industrial compliant products, their behavior, their configuration. Okay, and you have to just drag and drop those components from these catalogs. Okay, any of the catalog in your workspace. So with the help of that, you can build the like the industrial compliant circuits, right? So in this way, the manufacturer's catalog will look. So this is the partial list of our industrial clients. We have clients like NASA, Boeing, John Deere, Kubota, Caterpillar, Hitachi, L&T, US Steel, China Steel, Epiroc, Honda, RB High-Tech, Terex. Okay. So let's move to the software part. Okay, so I hope the software is visible to all. So I have not opened any file, so I will just go to new project here. So here you will see the welcome screen. So we have different templates like as per the technologies like electrical, PLC, robotics. Okay, today we are going to explore this. Okay, template like you can see. So here I will go to default. Okay, because we are going to build a circuit using the Siemens PLC. You can see Siemens PLC. So, what I will take, I will take one directly listed PLC. So here you can see the PLC. We have different PLCs like Allen Bradley, IC Standard, Siemens. Before that, I will just give an overview of the software interface. So this is the interface of Automation Studio 9.0 SR1. On the left hand side is the Library Explorer where you will find all the technologies. Right from hydraulic, proportional hydraulic, pneumatic, drive and transmission elements, and momentum control, instrumentation, process control diagram. Okay, so we have added this in the ninth version. Then we have electrical control JIC and IC standard. We have separate library for digital electronics and ladder diagram for Allen Bradley. Then IC standard Siemens PLC, LS Electric Mitsubishi, electrotechnical IC and NEMA standard, electrotechnical one line, then blocks, HMI and control panel, and robotics. You can see on the right hand side is the project explorer where you will find the current project on which you are working. The top bar is the ribbon bar where you will find the tabs like home tab, edit tab, view, simulation, system analysis, fluid, tools, student tab for students, and then support, and then technical training material tab. Okay. Then okay, so let's start building the circuit. Okay, so to build the circuit, like PLC circuit, we need the PLC, right? So here from the electrical control also you can take these PLC cards, the basic input output cards you can take, right? So, but I will take the illustrated PLC. So here you will find the illustrated library, which is in the orange color. You can see when I just click on this symbol, so library will open, which is of illustrated library. Okay, and you will find illustrated components for different technologies like aeronautics, DC electrical, residential electricity, then again input output PLC cards, motor control renewable energy, residential electricity, then cylinder plus load, hydraulic illustrated components and sectional components. Then we have illustrated library PNID components, one line illustrated components. Then we have illustrated PLC here, which I will open here. Okay. And then we have pneumatics illustrated components and then sectional components you can see. Okay. So you might have seen the these components in the previous libraries for hydraulics and pneumatics. Okay, you might have seen this. So I will open this only. Okay. Okay. So first I will take the illustrated component, um, like for the PLC. So when you just open the illustrated library for PLC, you will see like different PLCs like Allen Bradley. Okay. So they here you will find like for standard diagram. Okay, and then for electrotechnical diagram also. Okay, so you can use it accordingly. You can see the Rexroth also, Eaton, Koyo, LS Electric, Mitsubishi. Okay, so we will try to arrange webinars for different PLCs. in the future webinar series. So for today, we have selected the Siemens one. Okay, so you can see we have different Siemens PLC. Yeah, so mostly we have seen that Siemens PLC is used, right? So we will use this. So here there is a feature of zoom component. So you can use this feature where you can uh, see these components before actually using it in your schematic. Okay, you can see. So I will take this here and take this. Then I want to take a ladder. So I have taken the Siemens PLC. Then you can go to Siemens ladder diagram. Okay, and then we will configure this. Okay, so I will go to generic components. Yeah, again. So here there is no space. So here, like you can also increase the page size. In the home tab in under the documentation, you will find the page setup. So I can just increase the page size. Okay, I will zoom the page and I will adjust this. So what we are going to do, so we will create a basic like hydraulic circuit, which we will link it to proximity sensors for the automatic uh, extension and retraction of the cylinder. Okay, with the help of this PLC, right? So let me build that circuit. So I will take unidirectional pump with shaft, hydrostatic reservoir. So this is the basic circuit which you all know, or you might have seen in the previous webinar. Okay, take a variable relief valve here. You can change the orientation with the help of the shortcut keys also. So I will connect this. It's very easy to connect. So here during connection, you can change the line type also. For example, this is the return line. Okay, so you can see, so it will change. So okay, or I will zoom the page. I need one engine or a motor, so I will take one motor only. Okay, yeah. So it was very easy to create one hydraulic circuit, and I will link one like two sensors to this hydraulic circuit quickly. So for that, I need to go to hydraulic library. I'll go to sensors, and here you can see the proximity sensors. You will find the components of different standards. So we have 2012 and no standard one. I will take 2012 one. You can take no standard one also. Okay. So I will link it to the cylinder and I will name it as this one. Okay. I will take one more sensor and I will name it as S2. Okay. So you have to link it carefully. Here I will give the 100% extension and then I will link it. Okay. And then again I will give it 0. Okay. Yeah. Okay, so sensors are now linked to your hydraulic circuit, and then I will make the connections here to the PLC. Okay, so just a second. Yes. So here, we have to take um, power source. So I will take an L1 here. Okay, so I will zoom here so that you will see it clearly. This looks like your the exact PLC which you are using in your practical lab. Okay, so I will take a L1. Okay, power source, then a neutral. I will take I will take a ground here. Okay, and then I will also take a 24-volt here. I will take a um, common also. Okay, common here. So we will make the connections here. So we will link or connect L1 to L1. Here you can see neutral to neutral, and ground here, right? And we will short this ground. Okay. Now I need to like bring switches here in the workspace, as we have used the proximity sensors here. So I need the proximity switches also. So I will go to frequently used components. So you will find mostly the frequently used components here only directly. No need to search inside the library. So I will take one proximity switch here. Okay. I will take one more proximity switch here. Okay. And I will take one push button also, just to give a start. Move this here. Okay. Okay. So now we can make the connection quickly. Okay. So it is very easy to make connections in the automation studio. So a student will not feel any difficulty while making the connections or to understand, right? Then we will need solenoid. So I will drag the solenoid here. Okay. I will give the name simple name here, extension, and then for retraction I need one. Okay. Mm, yeah. And then we can make complete the connections here. Okay. So we have completed the PLC connection, but we have to give ladder logic also. Um, okay, so here I will go to Siemens PLC, and then I will take normally open contact. I will take a copy of this again. I will take normally close contact here, and I will take a output here. Okay, so easy. And I will name this as extension. Okay. Similarly, I will take a contact here also, as I want the automatic motion, okay, of the cylinder. We'll take this, and I will take one. Oh, so this is wrong. I will take one output coil again here for retraction. Okay, and again we will take this one, and we will complete this connection. Okay, yeah. So if anybody has any question, please type your questions in the question pane. Okay. Okay, right. So I have created a ladder logic. Okay, so I have connected some like contacts here, but I have to link this ladder, okay, this context to this PLC. So I will adjust this. Should I zoom in? Okay, yes. So my first contact should be to like 0, okay, input 0. So when I will push this button, then only the sensors will work, right? So when I double click on this contact, so it will take me to variable assignment, and here I can link it to inputs. Okay, so you can see here it is connected to input. So I00, okay, I will link it to I00. You can see it is linked. Similarly, then the first proximity switch is to point 2, 0.2. Okay, so I will link it to point 2. So when my point 2 is giving the input, my point uh, 5, point 5 should be close. Okay, so this is normally close context, so my point 5 should be close. Okay, and so my output should be to out 0, 0. So it is out 0.0. Okay, and for the second one, we have to give this to extension. So extension Q00. Okay, yeah, and then we have this one. So my first row is complete. Similarly, we have to give like link the variables to the second row. So second one is like similar one only. So here we have to give input to point 2 first. 2. Okay, and then my um, 0 0 should be close, and this output should be to Q uh, point 4. Okay, and then here you can search for the retraction. Okay. Yes, so you can see this is linked. Okay, so we have connected the PLC. Okay, and now we have to connect this whole PLC circuit to this hydraulic circuit. So extend, and then oh sorry, this should be the retract. Okay, so I will zoom this page. Okay, uh, yeah, it will not be there in one page. So yeah, zoom page. Okay, and then we will start the simulation. Okay, so you can see how it is working. Okay, how this is working. Okay, and let's see. It's not working well because there is some mistake here. Yeah, so we have made a mistake, not a mistake. We have forgotten to connect these proximity switches to these sensors. Okay, so I will connect this to S1 and then S2. Okay, simple. And then we will start the simulation. Okay, now it should work. So I will push this button and you can see how it is working. Okay, it is not retracting. Okay, extension is given, retraction is not done. Uh, Maybe something is there. hmm So let me check. And we will start for retraction, search for retraction. Maybe this is the one. Let me check. And same for the extension. Okay, let's see. Okay, so again, there is a mistake here. So yeah, so that is why like when you are connecting, you should connecting properly. Okay, otherwise, yeah, maximum temperature and extension. Okay,
Saurabh,
hmm.
yes, you can replace this I 0.0 in the second rung with I 0.5,
Yeah,
the
same.
normally closed contact. Yeah.
Yeah, so thank you, Rohan. I was not getting well. I made the mistake. Thank you. Yeah, let's see how if it is working well now. Point two, yeah, still it is not working. Point one, 0.012, and this one should be your 0.2, right? So I have made the mistakes in connection only, so that we have to properly. hmm Yeah, so this we have made the connections. Okay, so in this way you can make the PLC connections. Okay, you have to connect it carefully. Okay. Okay. So this was about the illustrated PLC. Okay, and connecting to proximity sensors. Right. So you can try the circuits in different ways. Okay. Now moving to the like the virtual part again. Here you can see different templates of virtual trainer kits. So if you just go to PLC, here you will find different trainer kits for virtual trainer kits of different PLCs like Siemens, AB, like Allen Bradley. Okay. So if I want to take one first, I will take this. Okay. So I will save this. Okay. Maybe if we are okay. Webinar PLC, I will just save it and then I will open it because in educational edition you can use one file at a time. Okay, so here like in this way you will able to get to see the templates of virtual trainer kits. Okay, so here this is the template for Siemens S7 1200 with some other components also like push buttons. Okay, lights, HMI lights, then pneumatic cylinder. Okay, you can see the pneumatics also. And here again you will get the Siemens ladder. Okay, if you want to create the circuit. So let's try to make some connections here. Okay, so I will connect it. Let me zoom this. Okay, so here first I will connect this power. So this is like power. You can connect this power to L1. So as we have done in the previous circuit, here you can see the actual banana cables, and you can also change the control to black, blue, red. For example, I am keeping this black only, so I will make this black. Here okay, you can adjust the line also. You can add the nodes in between. For example, if I want to add the node, so I will add the node in between. Okay, you can add the nodes in between, and then I will adjust the line here for now. Okay, so this is the center one is your ground. Okay, for ground I will change the color. So maybe I can make it to blue. Okay, and then I will make this connection here neutral. Okay, I will change this color to red. So here you can observe like these are the actual banana cables which you use it in your practicals. Okay, lab. Okay. And here I will make the other connections also, right? So I will connect this push button to L1. Okay, and then I will short. Okay, again, and I will connect this push button to again 0, right? So here I can change the color again, so make it red. So I will make a simple connection here, and I will connect this L1 to here to output. Okay, so I will give power to output also, and I will connect this 0 to this HMI light. Okay, you can change the color, and then we will this output here. Okay, and we can start the simulation, and you can check if it is working. Okay, okay, so you can see our PLC is working. Okay, but the light is not glowing. So control. Okay, so here I have made the connection to 0. Mhm. Okay, so again I had made some mistake. Let me check. Sorry, this we have to make it connection, and then we will So what is not working? Yeah. So again here. I don't know like why it is not working. So let me open the file for you directly. Okay. Okay. Okay, so this is one example which I have already created. So this is the same like PLC, the same example. Okay. And you can see how it is connected. Okay, when you can will start the simulation. Okay, you can see the automatic extension and retraction of the cylinder. Okay, so here again it is linked to the sensors, right? So when we push the button, you can see there is a timer also attached to it, to this ladder. Okay, right. So there is a preset you can see of 3 seconds. So in this way, like you can make the connections. So you will find such files in our website also, in our demo files. You can use it. And similarly, like if you want to use other PLC, so we have different again PLC templates. Okay, and here like okay, you can see this kind this PLC again. It is 7 S7 1200. It is linked to toggle switches and the lights. If I want to connect this, so you can make the connection here. And right, so okay, and you can make the connection. So one row I'm connecting the simple connection, and the second row I will attach or bring a timer. So here you can see different types of timers like on delay timer, then off delay timer. Okay, extended pulse timer. So I will take one simple on delay timer here. Okay, and when you just double click on it, you can see the properties of it, the time based value, then preset. So it is having the preset of 10 seconds. Okay. Oh, so here I will bring one contact again, and then one output again. Okay. Yeah, so here I have to link this. So already the toggle switches are linked to this Siemens PLC. So this we will link it to I00, and this output again we will link it to here. You can link it to I0, sorry, Q00. Okay. Here you can I will link this second toggle switch which is to I0.1. Okay, and you can see, and this output I will give it to Q 0.1. Okay. Okay. So we'll start the simulation. Okay, and I will adjust the diagram sheet. Okay, and here when I am using the first row, you can see it is um, the logic is applied directly and the light is glowing. But when I'm clicking on this second one, toggle switch, it is taking time. You can see the timer here. Okay, the timer is running, and when the time will be zero, the light will glow. Right? So in this way, you can make the connection. You can use the components from the libraries. Okay, to create different types of PLCs. Okay, yeah. Okay. The last part which I wanted to show is one industrial example of AB PLC. Okay, so I will open this. Okay, yeah. So I will just close this, adjust the screen here. So here you can see different ladder. Okay, yes. So this is the 2D. I will expand it. This is a 2D virtual system which is created in Automation Studio. This system is linked to this PLC. Okay, ladder logic. Okay, this is Allen Bradley 500. Drilling factory example, which I will start. Okay, start the simulation, and here I will push this button. You can see how it is working, how the ladder logic is working. So again, this PLC, okay, these PLC cards are linked to this ladders. Okay, in these ladders again there are timers attached to it. Okay, so you can see this. I will expand this screen, how it is working. Yeah. Okay. Okay, so that is all from my side. I will show one more example. But if you have any question, you can ask me in the in the question ban. So one example of Mitsubishi ladder. Okay. 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 So this is the Mitsubishi ladder, which is linked to this small electrical circuit. Okay. So I will. So you can see. Okay. So whenever you are clicking on this thermomagnetic circuit breaker, so this HMI light is glowing, and again here you can see the count. Okay. Okay. Okay, so this was about the PLC. Okay, yeah, so that is all from my side regarding the like today's webinar. Okay, so if you have any question, please let me know. Um, yeah, so I can see some questions and right. Hmm. So so I cannot explain now the whole again the circuit again, but you will receive the recording link. Okay, those who have attended, you will receive the certificate and the recording link tomorrow, so you can check that recording tomorrow. If you have any question, you can email us. We can arrange one demo for you, online demo, where you can ask your queries and we can address them. Okay, maybe we can show you more on the PLC part, or we can show more based on your requirement. Okay, so that is possible. Is there any tutorial? So we have this like um, demo files on our website. You can look at that. If you are using the software, you might have received the user guides. So with the help of that, also you can work and learn. Uh, yes, if you want to work on like PLC program in Automation Studio, you need to purchase the PLC separately. Okay, if you are using the premium version, then you will get that PLC directly in your package only, but you need to purchase the PLC. Um, See, like there is no like free software as of now for the students. You have to purchase the software. Okay, like we can contact you and you can let us know the number of licenses you are willing to purchase. Okay, and you can do it. So variation in the versions, I can explain you through call. So maybe we can call you and I can explain you. Acoustics, module related to acoustics. I did not get you. Can you please explain? Oh, so professional edition is usually like it is given to only industries. Okay, and for students, like it is the educational edition. Okay, there are some limitations with respect to the professional edition and the educational edition. Okay, so and in terms of price also, live manifold it is different. It is totally industrial. Okay, so this will be not for the educational. Yeah. Yes, so for the licenses and the other commercial thing, we will call you, we will contact you, okay, and we can discuss on that. So we have few more webinars left, okay, which are there in next week. You can see the details. If you have not received the invitation, please let me know. I will send you the invitation. So those who have not received the invitation, please type it in the chat box, the question pane. We will, okay. Okay. So again, if you need any demo or you have any question related to software, please take this email ID. This is my mail ID. You can email me the questions and I will address you. Okay. So thank you very much for attending today's webinar. So we will see you next week. Okay. Yeah. Thank you very much. Have a good day. Bye.